Morning everyone. Everything's looking good my end. So welcome, Monday morning again, 10 o'clock. And a quick kind of intro to the session again, just in case anybody's new. We've been running these for about 3 years, every Monday, 10 o'clock, starting at the feet and then working our way all the way through the body, going up and to the head. We did cranial nerves last time as well, which was interesting, and then all the way down the arms into the hands, and then we start again. So this is our third time round, and every time do try to improve it and add a bit more in. So this round we've been looking at specific pathology for the regions that we've been looking at as well. So I've been doing the anatomy and then a bit of pathology. So we're going to finish off all the anatomy first. And then we'll move into the pathology of the thorax and do a session on that as well towards the end. So that is the plan. Good morning, Steph. Good to see you in this morning, and Tris. And if anybody has any questions, they can put them in the chat if you're on live. If you're not watching live, then you can put it in the Facebook group and I will answer the questions in the week. Cool. Right, let's get going. So we've been looking at the thorax and been covering the ribs, the sternum, and the thoracic spine. So obviously the kind of cage around all of the organs that are in that area. So now we're going to have a look at the organs that are in that area. We always cover the blood supply and the nerve supply anyway. So what better blood supply to cover than the heart? I think we've got to do a heart session if we're up in the thorax, and we'll do the nervous system as well. So we'll do the nerves that are specific to the thoracic area. And but because of the region as well, that so obviously it's not like this in any other region, but we've got the lungs as well. So we're going to cover the lungs on a session, so that we've got all of the organs then covered, as well as the muscles and the bones and everything. So it kind of ties everything up, if that's okay with everyone. And if there's anything that you want to cover that is of interest to you, then just let me know and I can add it into one of the sessions. No problem at all. Cool. Right, let's get going. This is the easiest way to do the heart, to learn it. Just get rid of that. Where's it gone? There, perfect. So this is how I used to teach the heart when I used to teach at college. And it's basically draw a square and then divide that square into quarters, and then that is the structure of your heart. It doesn't look like that in real life, obviously, but this is a really good way to learn it so that you can remember the flow of everything and where everything goes. Okay, so what we're going to do is we're going to start in the top right hand corner, and then we're going to follow the flow of deoxygenated blood, how it gets oxygenated, although we'll do the lungs on a separate session, and then how that reoxygenated blood then re-enters the heart and then gets pumped around the body. Okay, so that's the plan. So if you haven't heard it before or never seen any words to do with the heart before, so we've got these letters here. So RA, RV, LA, LV. Apologies if you know this already, teaching you to suck eggs, but it's always good to start at the beginning, I think. So we've got the right atrium and then the right ventricle. So the right atrium, well, the top two atria, so the right, and that's left atrium as well, just a bit of a spoiler. So that this area here, these are the receiving chambers of the heart. Okay, and the best way to remember that is if you remember back to learning about the Greeks and the Romans. They had big atria, which were big hallways into their houses, and that atria is an entranceway, and that's exactly what we've got here in the heart as well. And then the ventricles down at the bottom, so that's right ventricle and that one's left. They are the pumping chambers. So we have the receiving chambers and then the pumping chambers, and it's as easy as that, simplified. Okay, so yeah, with there's a specific flow through the heart, because obviously your body uses oxygen day to day to for you to survive, for you to move. And we have had a look at these vessels on the last couple of sessions because we saw them as they came through the diaphragm. And we talked about something called the vena cava. So the vena cava are the big veins, okay? They're the main veins coming back into the heart. So here we have the vena cava here, and the vena cava receive blood from your lower body and from your upper body. So there are two vena cava. You have a superior, so the one from the upper, and an inferior, the one from the lower. So the one we've seen already is the inferior, because it came from the lower body and then pierced through the diaphragm to get to towards the heart. So we'll have a look at that today. And the upper body one we'll start to look at when we look at the neck and the shoulder, okay? Because you'll see how when we get to the blood supply section of that bit, we'll see how the deoxygenated blood then comes back to the heart. Okay, so we'll do it in kind of stages as we go. So yeah, so those are your main veins. So these are then coming, so deoxygenated blood coming back from the body, and they're received by this atria, so this entranceway on the right hand side. Now, when you look at that, you're like, well, that's on the left and that one's on the right. So why are they switched around? What you have to do, if you turn around so you're not facing the screen, and then imagine that square on your chest when you're facing the other way, it's basically the layout of the heart as if it was in your chest. Okay, so when you look at it, and when we describe it, the right side is the left side is the right side. But yeah, if it was yours, then it would be correct. Yeah, so the left side is your left rather than the person looking at you. Okay, so in between these chambers, these arrows here, they indicate where there is a kind of an entrance into the chamber itself. And if it was just a hollow tube and the blood went in like a slide, basically like a water slide, and the blood came in and then it just fell through here and then fell into here, you'd have no blood pressure. Yeah, the blood would just slosh around. So what you need are valves, and in between each of these lines there are valves that help to control the flow of the blood throughout the heart. Okay, so on one particular part of a beat, the valve will close, a chamber will fill with blood, and then on the other part of the beat it will open, and then the next chamber will fill as the blood goes in, and then it will close, and then that one will pump away. So they all work together, opening and closing. And obviously you can have problems with the valves where they don't work properly, and we'll talk about that when we get to the pathology. So wherever there's a line where we cross over here, or an arrow where we cross over here, there'll be a valve that helps to prevent backflow of blood into the chamber, because obviously if it's being squeezed out under quite high force, if it was just a tube, there's a chance that it may trickle back in again, but if it's blocked off with a valve, then it can't get back. Okay, so it will maintain the amount of blood that's in each chamber. And then we've got these lines here down the center, dividing the right side and the left side, and these are called septum. And a septum means a hedge. Okay, so if you have imagine an aerial view of a nice field in the middle of nowhere, and there's a hedge that divides two farmers' fields, the hedge is the septum. Okay, so that's where the name comes from. So it's basically a dividing line. Okay, and there's a divide between the ventricles, and there's a divide between the atria as well. And they develop as we grow from an embryo. Okay, so again, when you may have heard of things like hole in the heart, and that is where there is a hole in the septum. So if you imagine if there was a hole here and there was a problem here, then we've got deoxygenated blood and oxygenated blood, and they can start to mix. And obviously, if you've got deoxygenated blood that is then being pumped around the body, you're going to be pretty tired because you're not getting the oxygen that you need to be able to function. So these lines here indicate the septum. Okay, so again, if you're going to if you're going to follow along and draw, if this is the first time you're doing it, then that's a good label to put on this diagram. Cool, right. Enough of me talking. Let's have a look at an overview of that. So this is where we've been, and just pause that there. So we've been looking at the ribs. We've been looking at the sternum. We've been looking at the costal cartilage. We had a look at the intercostal muscles, so the muscles in between the ribs, and the effects that they have on the movement of the ribs, and obviously how they attach around the back onto the thoracic spine as well. So this section of rib has been removed, and then there is your lung. So your lungs fill a massive space, and then if you pull the lungs away, then the heart is in between. Okay, so obviously not a square like on my picture. It's more of a kind of like an oblong blob. And there it is there. Okay, I'm just going to pause that there. Cool. So the square makes it simple. Yeah, so we've got the right atrium, right ventricle, left atrium, left ventricle. But the shapes of them aren't the same. Yeah, so that, and the size of them is different as well. So the left ventricle will be a lot bigger than the right ventricle. So if that square is not a direct representation of the area within the heart. Okay, it's just to simplify it so it's easier to learn. So as we go through, you'll see how big the different sections of the heart are, and it explain to you why that is, because of the jobs that they do. Okay, so they have to adapt to the jobs. Now, you might notice this big vessel just here coming out of the heart. That one there, you may have heard this. We've not really mentioned it so far, but this is called the aorta. So this is your major oxygenated blood vessel. So it's coming straight from the left ventricle in the heart, and we'll talk about that in a sec. But it's coming straight from your heart, oxygenated blood, and then immediately you can see these vessels coming up here. So it's going towards your upper body and your brain. Yeah, so immediately supplying oxygenated blood to your brain. And then the arch of the aorta, which is this bit just here, that then descends. So this bit is called the descending aorta. It will pierce through your diaphragm, which is what we saw last time. And then it will go down into the abdomen, and then it will split into the iliac arteries, which is what we did when we had to look at the blood supply for the hip and pelvis region. Okay, so if you want to marry up the two videos, have a look at the blood supply for that area. So that is a huge blood vessel. If you've never seen it before, it's quite surprising how large it is. Just because I've done it before, you can fit your thumb in the aorta, no problem. Okay, of most aortas, because they're that big. Okay, they are really huge. They are very muscular because they're arteries. So they also they've got smooth muscle in, which help to pump the blood around your body. So they're quite they've got quite a thick muscular wall. All right, but that's your aorta just there. This bit here, that's your diaphragm. Okay, so we've seen that before. We've got the back of the thoracic cage, if you like, so back of the ribs, just there, posterior ribs, and then that bit there, that's where your xiphoid process is. So that's where your ribs come to meet at the front, and then there, that's the top of the sternum, so where the manubrium is, and then that bone there is your clavicle. So you can see they've just removed all of the ribs so that you can see the heart underneath. Right, let's have a look at that. Yeah, so there's your descending aorta. I'll go over these vessels in a sec. Oh, there you go. I'll do it now. Now that's come up. So these are the pulmonary veins. Anything where pulmonary is mentioned, that is to do with the lung. Okay, so we've got vessels that go directly from the heart and they go to the lungs, and they split and they go to both lungs. So when the body is well, either receiving or sorry, when the lungs are either receiving or giving, so receiving deoxygenated blood or giving oxygenated blood, they'll go through different pulmonary vessels. There are pulmonary veins and there are pulmonary arteries. So anything with pulmonary in it is to do with the lung. So it's either going to the lungs or coming from the lungs. Okay, and we'll talk about that as we go through. Is that it? Gonna have a look around this side as well. Yeah, so again, aorta there. Ooh, just there. Let me just rewind that just a sec. So just as it spins around there, on the left-hand side of the heart, I'll just see if I can pause it just before it goes black. There. Okay, so you can just about make out these vessels here. Can you see those? There and there. So these are your vena cava. Yeah, so we've got superior vena cava, inferior vena cava, and both of those then join together to come in through that top left corner of that square, which is the right atrium. Okay, so that's your receiving chamber of the heart for deoxygenated blood. Okay, cool. Right, so if we just go back to that, so those vena cava, that's what we've just seen there. Okay, so they go into the right atrium. This is deoxygenated going in, so that it can then be pumped to the lungs and then get oxygenated blood. Okay, the ones we've just seen on the video, the pulmonary ones, they were these ones, pulmonary veins. So the pulmonary veins come from the lungs back into the heart. So this will be oxygenated blood traveling through those veins. Now, this can be a bit confusing because sometimes very simply, when you're learning all this stuff about the cardiovascular system, you're taught that arteries have got oxygenated blood in and veins have got deoxygenated blood in. That is true apart from these. Okay, so these are the opposite. So the pulmonary veins, they are carrying oxygenated blood, and the pulmonary artery is carrying deoxygenated blood. So it's opposite to everything else that you learn for the rest of the body. Now, one of the ways that you can remember this is to do with the heart especially, is arteries away. So if you remember arteries go away from the heart, then they have to be going towards the lungs. Yeah. Whereas the veins, if you chop off the V and the E, they come in. Okay, so that's a nice little way to remember which way around they go when you're looking at the heart specifically. Like I say, everywhere else in the body, arteries have got oxygenated blood, veins have got deoxygenated blood, but in the heart, it's the opposite way around. So it does get a bit confusing. But arteries away, so AA, and then the veins, chop off the V and the E, they come in. Okay, so that's a useful way to remember it. Cool, right, let's have a look at that right atrium in a bit more detail. So this is our grid, okay, so our easy grid, and the atria, so two atrium, are behind the ventricles, they're not above. So in the picture, we do it just for simplicity, we draw it so it's above, but actually in real life, because of the way the heart is orientated, it's kind of like on its side. It means that the atria are behind the ventricles, and that makes sense because if you're trying to be efficient with pumping action, then it's easier to pump in that direction than it is up and down. Okay, so the orientation of the heart helps with the movement of blood flow. So the yellow stuff that you can see around the heart, that's fat. Okay, so there'll be pericardial fat, and there'll be more on some people than others. Depends on the lifestyle that they've had. But yeah, these are your ventricles at the front, and then these are the atria at the back. Okay, I'm just going to pause that. Oh, there we go. Okay, now If we have a look at, just move my arrow properly, there we go. So if we have a look at this picture here, so we've got left atrium just there. Okay, so that area there, that's the left atrium. And remember, it's receiving blood from the lungs. And if you have a look, we've got these vessels here and here, and these ones will go off in one direction to one lung, and these ones will go off in the other direction to the other lung, and they'll be receiving blood freshly oxygenated from the lungs into that chamber there. Okay, so that's your left atrium. Your right atrium is this one just here. Okay, and can you see that vessel there? Yeah, that one there. It's been cut around there. That's your superior vena cava. So that would be deoxygenated blood coming in here. And then that opening just there, that would be your inferior vena cava, where blood is coming from the lower body up into the right atrium just there. So that's this side here. So vena cava, right atrium. Okay, so there's the superior and then there's the inferior. So they're both coming into that bit there. All good so far. Okay, so we're going to have a look at this right atrium. So epi means upon, so epicardial fat means upon the cardium, which is the heart muscle. Okay, so we've got this layer of fat tissue over the heart. So that's what the yellowy stuff is. And then that's it, with it all taken away. Okay, so all the fat's been taken off, and now you can start to see the striation of the heart muscles themselves. So the heart muscle is a specific muscle. It doesn't work, it's not orientated like skeletal muscle, where skeletal muscle is aligned in like strips, and which kind of are like zigzags. These are straight line fibers, and they work differently to the skeletal muscle. So this is cardiac muscle. It's and then within the artery walls, you've then got smooth muscle. Okay, so we've got cardiac muscle that's specific to the heart, smooth muscle which is specific to the tubes around your body, so especially the arteries and the intestines. They've got smooth muscle too, to help with either movement of food or movement of blood. And then your skeletal muscle is obviously the one that moves your limbs, but they're all different. Okay, so they're all arranged differently and work differently. So that's your left ventricle just there, and there you can see where the gaps are. Okay, to for the different zones. Okay, so the atria just here, there's the ventricle, and you can just about make out the difference between the left ventricle there and then the right one just here. There's the right one. So the left one's a lot bigger than the right one is. And then as we come round, we've got the right atrium, which is just there. And then that one's the left. Okay, so that's the left one that we saw earlier. This is the right one. Okay, just here. Yep, so that's coming from the lungs, and that's coming from the body into the right atrium. So deoxygenated, oxygenated on that side. So you've got superior vena cava, and then just underneath there you can see an opening there. Inferior vena cava just there. So that the inferior vena cava is a lot bigger, because there's a lot more blood coming from the whole of your lower body than there is just from your upper body and your arms. Okay, so the blood vessel size is different. So here's your diaphragm. This is what we've been seeing over the last couple of weeks. There's your heart. Okay, and what we're going to have a look at in a minute is where the inferior vena cava comes through the diaphragm. So if we just move this out of the way, and there it is there. Okay, so we saw those openings last time. There it is there. Okay, so that goes straight into your right atrium of your heart, and that is that hole just there. So we've got coronary sinuses. Anything to do that's got the word coronary in it is to do with the blood supply for the heart itself. So you've probably heard of coronary arteries or coronary artery disease, CAD, and it's the first place the heart supplies with blood is itself. Okay, so you'll see when we have a look at the aorta, there are two little vessels that immediately come off of the aorta, which have got freshly oxygenated blood, and they go straight back into the heart themselves, so that the heart stays oxygenated, because obviously it's working 60 to 80 beats per minute every single day, hopefully. Okay, this is really cool. So this bit here, this is a auricle. So it's an atrial appendage, and what it does is it's kind of like a pouch. Okay, so it's auricle. It's called auricle because it looks like an ear. But what it does is when you get deoxygenated blood into the right atrium from the vena cava, if the atria needs a little bit more space, then it fills this auricle. Okay, so normally it lays flat, but it's actually a little pouch. So as it fills, it will then increase in size to take on board a bit more blood. So if you imagine when you're if you're doing exercise and you need a bit more volume of blood around your body, and obviously you've got to deal with the deoxygenated blood as well, then the auricles in the heart will open up so that you can use more blood during those activities. And then when you're at rest, they'll just close back down again. Okay, so that's what that auricle is, little ear-shaped appendage just there. It's pretty good design. Okay, we'll talk about these vessels as we go through. So yeah, this is the pathway of blood. If we just pause that there. So there's your right atrium. So blood passes this way. Superior vena cava, inferior vena cava. So if you match it up here, there's your vena cava coming into the right atrium, which is here. Okay, and then there's that line there represents that one just there. Okay, so where the arrow is, remember I said when an arrow crosses the line, there'll be a valve. So there's a valve between those two going from the right atrium to the right ventricle. So there'll be a valve around there, and then the blood will go into the right ventricle, and then from there it will go via the pulmonary artery. So remember, pulmonary is to do with the lung. So that deoxygenated blood then goes to the lungs to get fresh oxygen. Okay, so deoxygenated through these vessels into this chamber, through a little valve in there, which we'll have a look at in the probably next week, and then into the right ventricle, and then back into the lungs to get some more oxygen. Okay, let's have a look. And then this looks like the left side. Yep, so left and right atrium join up there. So let me just pause that there. So that line there, that interatrial septum. So remember I said the septum is like a hedge. So that line there, remember it's on an oblique angle, but we simplify it and make it that line just there. Okay, so during development, when you're an embryo, there is a hole between those two, and eventually it seals up. Okay, obviously sometimes things go wrong with it, but it should seal up so that it separates your left and right atria from each other. Okay, but that's the interatrial septum. So there's your right atrium again. So we're going to take a window into there, I think, on this one. Yeah, there we go. So that's inside the atrium just there. So there's your superior vena cava. Ooh, sorry. Move the wrong thing. Let me just lock that in place. There we go. So there's your superior vena cava just there. So that's the opening for that for the deoxygenated blood from the head and the arms. Okay, so coming down there, and then that one there. Okay, so you can just about make out where it's coming up through. That will be where the inferior vena cava blood comes in there. Now the vena cava are big veins, so the veins have got valves in as well to prevent backflow, because they don't have muscular walls. They rely on the being squashed by vessels. When you breathe, it helps to move deoxygenated blood via the inferior vena cava up towards the heart again, because the breathing action on the diaphragm helps to pump the blood up. The movement of your organs, the movement in your legs, especially in the calves, they all help to pump the blood back up to the heart. Okay, so movement is really, really important if you want to get good blood flow back to the heart. I think, is that it? Bear with me. I think that's it for that one. Oh, I think because I messed around with the picture. Ah, there we go. Yeah, that was it. Yeah, and there's your inferior vena cava just there. Yeah, so we've got the little coronary sinus, which is where... Oh, that's not working. Not pausing. Hold on a second. Bear with me a sec. So, yeah, that little coronary sinus... Hold on. Hopefully I can get this here. Yeah, there we go. Sorry, I've got multiple screens and they weren't locked, so it's causing havoc. Right, here we go. So superior vena cava just there, inferior just there, and then that little coronary sinus. Remember I said the coronary is to do with the heart. So if the deoxygenated blood from the heart itself, so from the vessels that surround the heart, will drain into the right atrium as well to get reoxygenated again. Okay, so that sinus there is where the deoxygenated blood from the heart will come in. So we've got upper body, lower body, and heart itself all coming into that chamber. And then that area there, that's the interatrial septum. So that's the area that I said in a embryo that it's not fully formed, and then it fully forms over time. Okay, so the heart works differently when you're in the womb because you use your mother's blood supply. You don't need your own. Okay, so but when you're born, obviously you do. So that should be closed up eventually. There we go. It's the fossa ovale. So from the foramen ovale that closes when you're born. Okay, so usually there's a little hole here. But when you're born, that closes up, and then you've then got a fully functioning heart. Okay, but like I say, you don't need that when you're in the womb because you're using your mother's blood supply. Okay, so that's the fossa ovale. And then as we turn it down here, hopefully we can see, there we go. So there's end on, and that is the valve that then goes into the right ventricle. Okay, so that's called the tricuspid valve, and it's because it's got 3 cusps, and the cusps are like parachutes. They're little triangular parachutes, and so they'll open and close depending on the timing of the beating of the heart. And when they open, they'll allow blood to go into the right ventricle, and when they close, then the right atrium will be able to fill up again. Okay, so that's a top-down view. So through that gap there, that will go straight down into the right ventricle. Perfect. I think that's it for that one. Brilliant. So let's have a look where we are on the journey so far. So we have gone from vena cava, so main deoxygenated blood coming from the body and coming from the head and the arms, so the superior and inferior vena cava, into the right atrium. We haven't got on this diagram the coronary sinus as well, but maybe I should add that in. Yeah, it might get a bit tricky with the simplicity. But the coronary sinus is the drain from the vessels around the heart itself. So that will be deoxygenated blood coming directly from the heart, and that goes into this chamber as well. It then goes through this valve, which we've just seen was the tricuspid valve, okay, through that area there into the right ventricle, and then from there it will get pumped via the pulmonary arteries away to the lungs to go and get oxygenated again. Okay, so let's have a look at that ventricle bit. Let's get rid of that. Get that one. Here we go. So these are the ventricles. If I just move that there. So we're missing the atria. Okay, so they've taken the atria away. So all that's left are the ventricles now. So we're going to have a look inside these ventricles. So the atria should be here. That's what we've just been looking at. So this is the right ventricle, and then the left one's over here. There it is. You can see the size difference is huge. We'll talk about that as we go through. And then this is a view of the where the valves are. Okay, so there's one valve, and there's the other one just there. So with the atria, hold on, just put that there. So if the atria were here, the left atrium will be here, so in front of this one, and the right atrium would be there. Okay, now this is a different septum. So remember before we were looking at this one, and that was the interatrial septum, so in between the atria. This is now the interventricle septum, in between the ventricles. So it's represented by that line there. Okay, so interatrial, interventricle. All right, and again you can get defects with both of those. So there's your these are your atrioventricular valves. If I just pause that there, just go back a bit. That was a bit quick. So atrioventricular valves. So because they go from the atrium to the ventricles, but they've also got specific names. Okay, so we've just seen that one was called the tricuspid, and that's because it's got 3 flaps basically. Okay, well we'll have a look at those when we get to it. And then annoyingly, the bicuspid, where it's got 2 flaps, is also known as the mitral, and is also known as the left atrioventricular. So that it's got 3 names for the same blooming thing. The tricuspid is also known as the right atrioventricular, so only 2 with that one, thankfully. But yeah, we've got tricuspid and bicuspid, or mitral, or atrioventricular. Okay, so they're but they all are the same thing. Okay, so when you're learning, it's really frustrating because you're like, I'm sure that was called something else, but it is, but it's the same. Okay, so there's your direction of blood flow again. So remember, we saw that with the atria on the back before. So from the atrium into the ventricle on the right side. And then if I just pause that there we go. Okay, so now, so this is the right ventricle. So we're here on the drawing, yeah? So the blood flow direction out of the right ventricle into the pulmonary circuit. Now the pulmonary circuit is the lung circuit. Okay, so we've got deoxygenated blood going into the lungs. That's then getting reoxygenated, and then the reoxygenated blood is coming back into the heart for it then to be pumped around the body. Okay, so from the right ventricle to the lungs, it loops around and goes out that one, and that is your pulmonary artery away. Okay, which is this one just here. So we've gone vena cava into the right atrium, deoxygenated, through that tricuspid valve, then into the right ventricle, still deoxygenated, pulmonary arteries away to the lungs, and then to go and get oxygen. So it's still deoxygenated at this time. And that's what I was saying, where it's confusing, where we think that arteries have always got oxygenated blood in them, not in the heart. So that particular artery has deoxygenated blood from the right ventricle. Okay, and then that will go off to the heart to go and get some more oxygen. There it goes, and that's it there. Okay, that's a whopper of a vessel as well. That's pretty big. Here's the direction of blood flow now. So let me just pause that there because we haven't really covered this bit yet. So now we're going to look. So it's gone to the lungs to go and get oxygen, and now we're on this side. So it's been oxygenated, and now it's going to come back into the heart to be pumped around the body. So normally there's an atrium just here, so the receiving chamber for the oxygenated blood which has come from the lungs. So that's just there. So let's have a look at this. So the blood flow direction is exactly the same. Okay, so this is the blood flow direction into the ventricle, so left atrium into left ventricle, so it's coming this way. That's the left ventricle. the left atrium has been removed. Okay, we'll have a look at that in a bit more detail in a second. So there's the direction. And then this then pumps the blood up and away through this chunky monkey, which is the aorta. Just pause that there, hold on. Okay, so it kind of loops back on itself and then goes out there. So there's the aorta there. Can you see these little vessels here? These are the ones that I was talking about before. So the very first place, they've obviously been cut, so you can't see the coronary arteries, but we'll have a look at those in the next couple of weeks. But as soon as the oxygenated blood comes out of the lungs, through the atrium, into the ventricle, comes back and pumped out through the aorta, it immediately supplies itself with blood again because it wants fresh oxygenated blood. So what we'll do when we look at the coronary arteries, you'll see why someone will have angina or they'll have a heart attack, depending on where the problem is with the coronary arteries. Okay. So there's the aorta. So your main aortic valve is there, just underneath there. So there's a valve in the aorta as well. So in between that line just there. Sorry, I was just talking then. Let's go back to this bit. Okay, so we're going to have a look at the right ventricle. Just pause that there. Now this is really cool. There is a better video than this later on, but you'll get a good glimpse of it here. Can you see these here? Yeah, so these are the chordae tendineae. That's how I pronounce it. Chordae tendineae, maybe? I don't know. I've always known it as chordae tendineae. But they are your heartstrings. And what they do is they attach onto the valves. So when the valves don't just open and close on their own, they have muscles that do that job. And the muscles are these ones here. Can you see that lump of tissue just there? I'll just move the arrow out of the way. And then it's got these little strings on the end. So these are called papillary muscles. So we've got these little papillary muscles and then these strings that come off of them that attach like onto the underside of a parachute. So when the papillary muscles contract, it will pull the valves open, and when they relax, just the force of the blood will close them up again. Okay, so on the tricuspid side, we'll have more papillary muscles doing that job, but there'll be papillary muscles and chordae tendineae for every valve. Okay, to open it and close it. This area here is really smooth. Okay, because you don't want very much friction on the surface of the heart to slow down the blood. Okay, so all on the inside there, you'll see it's really smooth. So there's your tricuspid valve. There's the pulmonary valve going up towards the lungs. So this is the right ventricle. And then, yeah, you've got all this kind of striation of the muscles, or the structure of the muscles. It's called trabeculi. Okay, so which is same name given to the structure in bone. It's got a very similar kind of pattern to it. So it's the inner muscle of the heart. So the wall of the right ventricle has this kind of weave pattern of muscle. But you'll notice on this side, one thing to try to remember is the width of this, or the depth of the muscle. Okay, and then compare it to when we have a look at the left, because it's very different. So that, yeah, that's your trabeculi, just the shape of the muscle, and then into ventricular septum, and then that goes up into the pulmonary artery. But it's all nice and smooth in there to allow that blood flow. Okay, cool. So where are we now? So we've gone pulmonary vein into the left atrium. We've gone through the mitral valve, or the bicuspid valve, or the left atrioventricular valve, whatever you want to call it. Then it's gone through the aortic valve, and then into the aorta, and then around the body. Okay, and also around the heart itself. Okay, so that is a kind of whistle-stop tour of everything in the heart. And the only bit that we've we've not covered in great detail is this left atrium. Okay, so we had a look at the left ventricle because the ventricles were together. So let's have a look at that. Here we are. Okay, so left ventricle and then left atrium should be here. Hopefully it will appear. So, yeah, so there's your left ventricle. Oh, this is a good one. This was the one I was after. So look at that. So these are your heartstrings. Yeah, chordae tendineae here. These are the papillary muscles that pull on the valves to open them up. And yeah, they'll literally just pull the flaps down to open it up, and then the pressure of the blood will then close them again the next time it beats. Yeah, so you got mitral valve, bicuspid, so only 2 cusps on this one, and then the aorta, and then this is the apex of the left ventricle. But look at the thickness of that. Just pause that there, hold on. Look at the thickness of that muscle wall compared to the right side. Yeah, so different. And it's because the left ventricle is the main pumping chamber of the heart. So if we have a look back at our diagram up here, your left ventricle is pumping all around the body, and you've got the ascending and then the arch of the aorta and then the descending as well. So and it's quite a big vessel, so it needs a lot of pressure to be able to push the blood through, because if it's not under a high amount of pressure, then it won't be able to force the blood through that big cylinder. All right, so it has to be pushed through under quite some force. So you've got the interventricular septum we've had a look at, and here we go. Yeah, so the shape of the vessels there, or the ventricle, sorry, so more like a C shape on this right side. Okay, so this is your left ventricle, and sorry, right ventricle here, and then left ventricle here. Look at the thickness on that. Crazy difference between the two, and it's because the right ventricle only has to pump to the lungs, which is not far. Left ventricle all around the body, so it has to be a lot bigger. There's the interventricular septum, so that's that line just there on the diagram. But yeah, the right side is more like a C shape, left side is more like an O, and you can see that these are the papillary muscles here. And you can see the heartstrings up there, the chordae tendineae, just there. So there's your mitral or bicuspid valve, just there. So 2 cusps on this one, rather than 3. So we've got an anterior cusp and a posterior cusp. And they will both, they're kind of like flaps, basically. So kind of like a parachute. So here are your heartstrings. These are the papillary muscles that attach onto the ventricular walls. So each set of papillary muscles attaches to a separate cusp. Yeah, so you've got different cusps, different muscles controlling each cusp. And these are all the ends of the papillary muscles just here. So they've been cut through here. So you can see they're quite thick muscles, and then the chordae tendineae or heartstrings just there. And then this is what it looks like. Okay, so you can see the papillary muscle there. Those are the heartstrings. And they're pulling open the valve, and then it closes again. Pulling open the valve, closes again. And then there's the aortic valve up there. Madness. This is a really good one. Look at this. Look at the thickness of that. Yeah, so we saw, remember I said, remember the right side. That was probably about 1/3 of the size of this. Yeah, this is huge. There's the papillary muscles, the heartstrings attaching onto the underside of the valves. And this is the outflow through the aortic valve, just there. Okay, so blood will come in through here and then sweep back around and then out through there. This muscle will contract really hard to squeeze that blood out of the aorta. There we go. So there's your blood flow there. So it's coming in through the atrium, out through the ventricle. Cool. Good. Oh, I've run over a bit. Sorry. I think it's worth it though. That's a pretty good video to finish on. Okay. So there is there's your heart. Yeah, pretty cool. We're going to go into a bit more detail on the valves next time. And we'll also have a look at the coronary arteries as well, so that you can see those. So yeah, that's a it's quite an in-depth introduction to the heart. But if you start off with that square and then start building on that, then you can't go wrong. Okay, cool. I hope you enjoyed today. I will see you next Monday, 10 o'clock. See you then.